In section 10, we're going to begin working on some rudimentary ideas in statistics. And in 10.1, we're working on analyzing surveys and samples. We want to look at how to identify populations and sampling methods. And our key vocabulary here is survey, population, sample, biased sample, and a biased question. So when you're talking about a survey would be an instrument for the collection of data that would be distributed to a group where they could register their opinions or their responses to different types of information. And when you're looking at that, typically a survey is administered to a sample. So when you're looking at this vocabulary, a population would be the total number of people that we're interested in trying to understand. As an example, if I wanted to do a survey of student opinions here at LaSalle High School, the population would be the students of LaSalle High School. It is unlikely that I would go ahead and try to give my survey to every member of the population. Instead, I would try to select a subgroup of students that was representative of the population, and that would be my sample. So the population is the entire group of people, and a sample is a subset that is representative of the population. A biased sample would be a subset that was not reasonably representative of the population. And my survey is typically composed of questions and or statements that you respond to. And a biased question would be a question that does not maintain a neutral stance on the topic that is being measured. Okay, so let's take a look at, again, a survey is a study of one or more characteristics of a group. The entire group you want information about is the population. If I do actually survey the entire population, that's called a census. The United States does that regularly of its population. And when it's difficult to perform a census, which is true most of the time, you could survey a sample, which is a portion of the population. In a random sample, so now we're talking about sampling methods, every member of the population has an equal chance of being selected. In a stratified random sample, the population is divided into distinct groups, and the members are selected at random from each group. And again, each member of the population still has an equal chance of being selected. It's just they've also been broken down, the population's been broken down into other subgroups besides the sample. Okay, so then you want to make sure your sample is representative of all those groups. A systematic sample is using a rule to select members of the population. You'll notice it is not necessarily random. Okay, a convenience sample is when only members who are of the population who are easily accessible are selected. For instance, if I just surveyed the students in my class, that would be a sample of convenience. In a stratified random sample, again thinking of LaSalle, if I split LaSalle into different grade levels and then made sure the seniors, the juniors, the sophomores, and the freshmen were all equally represented in my sample, that would be an example of a stratified random sample. Systematic might be, I select every 10th student to arrive in the school. It's a system, but it's not random. Okay, and in a self-selected sample, members of the population select themselves. So for instance, I might put my survey online and send a message to all the students saying, hey, take my survey. Then only the students who chose to participate by volunteering would be studied. This is also, these bottom three all have some level of bias within the sample. Okay, as an example, owners of a company with several factories conduct a survey to determine whether employees are informed about safety regulations. At each factory, 50 employees are chosen at random to complete the survey. So we've separated the population into different groups based on where they work, which factory they're assigned to. And then within those groups, we're choosing them at random. This is a stratified random sample. The population is all of the employees of the company, and the methodology is stratified random sample. If we change that just a little bit, and we look at this example, and instead we just question 50 workers chosen at random from one factory, this is likely to result in a biased sample because there's nothing to say that those members of that one factory represent the views of the workers at the other factories. For all we know, this one factory has a boss who's a real jerk, and so they have a different view of working for the company than the members of the other factories or the employees of the other factories. Okay, so a biased sample is a sample that's not representative, right? We're ignoring the views of all the other factories by only looking at the employees of one factory, and that introduces bias. Okay, when we talk about questions and biased questions, these are potentially biased questions. And the reason they're both biased, so let's look at them. Don't you agree that the voting age should be lowered to 16? Because many 16-year-olds are responsible and informed. If you look at right here, they're giving the rationale for lowering the age within the question. They're trying to persuade you it's a good idea in asking the question. Also, this opening phrase, don't you agree? Would you agree would be okay. Would you agree that the voting age should be lowered to 16? That's an unbiased question. But once you say, well, don't you agree? That's like, come on, you must agree. I agree. It implies that I agree, that the person asking the question agrees. Do you think the city should risk an increase in pollution by allowing expansion of the Northern Industrial Park? Well, right here, you're basically given the reason to not do it again within the question. They're implying that there is risk in allowing this expansion. They're not just asking, do you believe the city should allow expansion of the Northern Industrial Park? That would be an unbiased question. Okay, so this is just some basic overviews of sampling and populations.